jump into the intro here in a minute.
Okay. Have you got the soundboard as well?
Yeah, the soundboard's there. Ben, is your recording still going?
Yes.
Okay, I didn't know what crashed, so I didn't.
Yeah. No, my internet just. I'm now on tethering. AT&T should be more stable.
Okay, that's always fun.
Yeah.
Feel free to, if there is any connection issue, feel free to drop the video. Sometimes helps. But,
Okay.
or if you just want to save some of your mobile bill, your cell bill,
Unlimited data.
leave your video on then.
I'm actually amazed. I've tethered on mobile before, and it uses data, but it's really hard to hit the unlimited caps. You'd have to
I can say
tether
this.
every day.
If you have kids who run YouTube, you'll hit those caps no problem. Like, I don't think
Jon,
my
can't-
daughter understands the internet is something that most people don't have driving down the road. And she's like, I need the internet.
She shouldn't really be driving at her age as well. She's only 2.
Well, I mean, she's in the back seat, but
oh right, yeah.
yeah, like literally our cell phone plan right now revolves around the fact that I pretty much need to tether on long drives with her.
Mm-hmm.
All right.
I know, it's amazing. It was amazing.
I mean, I can't say much. If I was a kid, I would have wanted it too. I would have been like, give me that internet.
Yeah. Cool.
Okay. I'm assuming, hopefully people can hear us if there's anybody here. I don't actually know if anybody's watching live or not. So
Yeah, we don't
just so
get
you guys
lots
know
of
for
stuff.
context, most of the time the live thing, we stream it to YouTube. And there's some listeners, but it's not like a massive number. Most people are going to listen to the actual podcast. So if there's anything you don't like about the episode or you want edited out, you can let us know and we can let the editors know. They don't change stuff for Matt and I ever, but for guests they seem to do it.
Yeah, just jot down the timestamp and put it in the doc if there's anything. But if like you speak and then you go, let me start again, and then you start again, they'll just get the started again version. They'll edit that very naturally. It's just if you think of something later that you wish you'd said differently or not said, that they can cut out something, then just keep a note
Sounds
of
good.
it.
Makes sense.
Yeah.
Why does it
Yeah,
say
makes sense,
Ben's in the waiting room again?
Now we have 2 Bens.
Yeah.
Now we have 2 of me.
All right. So Ben,
Sorry
your
about
local
that.
recording is working, right? I'm only asking because like the amount of disconnects you've had, I can't promise Riverside's is going to work. So I want to make sure your local is actually working correctly.
I guess the answer to that, well, yeah, we don't know. Maybe a third Ben will join and tell us.
I mean, I hear clicking, but I don't know if that's him anymore.
Ben, are you still there?
It's not me.
I'm willing to give it a minute and see. Then we can go from there.
Yeah. I mean, what we'll do is we'll just carry on chatting. Ben's in and out,
Yeah.
Hopefully
Yeah.
he's in.
I guess I'll just jump in with the intro now, and I can introduce Ben and just say he'll be joining us if his internet permits.
Yeah.
All right, I'll start that now.
Let's do it. It's go time.
Hello and welcome to Go Time. Today we're going to be talking about GraphQL, and we are joined by 2 guests. The first is Mark Sandstrom. Mark is an engineer on the platform infrastructure team at Khan Academy. Mark, how are you?
I'm great. Thanks.
Well, thanks for joining us. Our other guest is Ben Kraft. He is the creator of the Gen Client, and he also used to work on the platform infrastructure team at Khan Academy. Ben, how are you?
Doing well, thanks.
Awesome. Well, hopefully Ben's internet sticks with us. We've had some issues before we started, so if he cuts out, keep that in mind. All right, so let's go ahead and just jump in. Getting started. What is GraphQL?
John,
Matt, you want me to introduce you?
Yeah.
Come on. All right. Sorry, everybody.
Treat me like
We're
a
also
guest,
joined by our other host, Matt Ryer.
Hello.
Matt, how are you?
Thank you for remembering me. I'm yeah, doing fine, thanks. Very glad to be back. It's been a while, but it's fun.
It's
I'm
been a
looking
while for
forward
me
to
if you
this.
can't tell based on my terrible introduction for you.
No, it's all right, really. I know sometimes when I'm not the host, I tend to mess around and be silly and stuff. But John, out of respect, well, no, I'm going to obviously carry on. I'll just carry on actually doing that probably.
All right. All right. We're going to first start off by just talking about what is GraphQL. So Ben or Mark, do either of you want to take that?
Yeah, I'll take this. Yeah, so GraphQL is a specification for building APIs. It consists of a query language for fetching data and also a spec for implementing GraphQL servers. It can run over any transport, but is usually run over HTTP. You send a query to the server, usually as a post request. If you squint, a GraphQL query kind of looks like a JSON document without quotes or colons or scalar array values. So pretty much what you're left with is the keys and curly braces, and that isn't a coincidence. The query document describes the JSON data to be returned by the server. So the structure of the data that you're requesting is specified in a schema that you write. And so your schema might have a type called user, and the user would have an ID and a name and perhaps friends. And friends could be an array of users. And if you follow that through, like, those friends could have friends, and a little bit later we can talk about why that's okay in GraphQL.
I guess the way I like to think about GraphQL is as a solution to some of the classic difficult API. And so say you have an API and you want to get the current user, but different pages want to get different pieces of information about the current user. So one page might just want their ID and name, and the other page wants their friends and their friends of friends, and some whole complicated thing. And GraphQL lets you just define one schema that can cover all of these, and then each page just says, I want this data, and then the server can send back exactly what it needs, instead of having to write either call a bunch of different API calls from each page, and then you get a bunch of round trips, or having to write essentially an API call for each page, and then you have to kind of duplicate a bunch of things. GraphQL says, we're just going to generate have this whole schema. It says, here's what I want, and the server just sends it back, and it's all in one API call, and it makes things super easy.
Yeah, I know when I first looked at GraphQL, it kind of struck me as something that somebody on the client side would have dreamed up. Whereas when you look at a REST API, it looks like somebody on the server side dreamed it up, because it literally just tends to mimic exactly what's on the server side. They're like, I'm doing no data transformation or anything. You can deal with that.
Yeah, that's right. It puts a lot more work on the server to say, here's what the client wanted, and now I have to do all the glue to put it together. But that in when you're actually writing a GraphQL server, most of that's going to be in your GraphQL library. And so you still just write the application code.
And Ben, you mentioned REST APIs. I know there are some out there that have been trying to sort of solve this problem. Stripe is one that comes to mind, where I don't know if you're familiar with their API at all, but they have a way when you're making REST requests that you can include it's I think they call it include. It's an extra parameter, so it'll actually give you information about nested resources. But then it's always been interesting to me that GraphQL is something that just had that baked in from the get-go, and it seems like you can go, like Mark, when you were talking about how you could have a user with friends, and those friends objects are probably going to be user objects of some sort, and you could literally nest that down several layers deep, and it just kind of works in GraphQL, which is kind of crazy.
Yeah, that's right. I mean, it's considered an anti-pattern in GraphQL to have fields that are just IDs. So friends wouldn't return a array of friend IDs. Instead, you can select into that object, and that prevents you from having to stitch together the data on the client.
But yeah, I really think of GraphQL as sort of, you take that kind of choose which fields you want in a REST API and you like really supercharge that. You make it the whole thing. You can nest it. You can, that's just the way the whole API is structured. And that's GraphQL.
Yeah. You can also tailor fields a little bit more to the client. Have denormalized data, for example, if you want, because it's okay. The client doesn't have to select a field if they don't want. So you can really, include additional things that are just especially handy for the client to select directly.
Yeah, and so you often, I mean, I think at Khan Academy, our user had, like 100 fields, because you just kind of, anything anyone needs anywhere, you just put it somewhere useful. And then, most clients are only going to select like 5 fields. And that's fine. They don't pay for the others.
I think that's something that, like me personally, I wouldn't have thought about at first, because I have a lot more experience just making, JSON RESTful APIs that send that data back. And if your objects aren't too big or there's not too much there, it doesn't make much of a difference. But like you said, if you have a lot of different use cases where the information for a user, you might need a lot, it is nice that you can throw it all there and not worry about the fact that that could be really slow if you had to send everything. So GraphQL, Mark, you mentioned that it's kind of looks like JSON when you're writing these queries, and then the data you get back actually is JSON. That's correct, or is that correct?
Right. Yeah, that's
okay.
Right.
So I'm assuming that means that there's both like a server and a client part. So can you elaborate, I guess, a little bit more on that part?
Yeah. So a GraphQL client is pretty simple. You package an operation and a JSON payload, and if you can make a HTTP request, you get a JSON response back, and clients. That's the basic, the kind of just basic thing that a client needs to do. And client libraries can provide additional facilities to make certain use cases easier. A server is a lot more complex. It takes the query that you send it, parses it, and resolves the data. So in the user example, it's resolving ID and name. And each field can be associated with a function on the server, and that function is only called when you ask for that field. So that's what solves the nested friends issue. You can't actually write a GraphQL query that's infinitely deep. So therefore, you wouldn't end up in an infinite loop in your server trying to resolve friends of friends of friends. Fields can also take arguments, and so really each field is like a function. Some are really simple and some are more complex. Not every field needs to correspond to a function. You can, if you have a user model where a bunch of the fields are available, you can return those all together. And in Go, one of the nice things that each separate resolver function is resolved, like in GQLGen, is resolved in a separate Go routine. So they're resolved in parallel.
So you mentioned GQLGen, and Ben had created Gen Client. Just so people know, I guess, when we get into this, GQLGen is a library that helps generate the server-side stuff.
That's right.
And Gen Client is something for the client side, correct?
Yep. Yeah, that's right. And we've talked about JSON, or mentioned JSON a few times, and so one way to handle JSON in Go, or the way that JSON's handled in the JSON package, is via struct tags, and so there are some libraries that use struct tags to help you generate queries and interact with the GraphQL server, and then code generation is another popular strategy.
Matt, you had said before we started the show that you've written, I believe you said you wrote, was it a client or a server with GraphQL?
A client, yeah.
So when you were writing that, do you remember what library you were using?
I wrote the thing. I wrote the client library.
Okay.
I wrote the Machinebox GraphQL client library is what I was on about. Yeah.
Okay.
Thanks for bringing it up. Yeah.
No problem. So when you were writing it, what language were you writing in, Matt?
I was writing in Go, and I was consuming a third-party GraphQL service. And at the time, there wasn't a way to do it, but you can just do it with, it's normal HTTP, as long as you get the request body that makes sense for the server. And I think you pass the query in as a parameter, but it is like a JSON-esque sort of query language. You just pass that as a string in a post request, and then and I think I sort of in the client library that we wrote, it would just use the normal JSON unmarshalling kind of thing for the response. So when you unmarshal it, or when you ask for a request, you give it an object or a pointer to an object like you do with the JSON thing, and it just passes it through to that when it does the unmarshalling of it. So quite a simple. It's like a very simple, lightweight library. And it was very quick. It was very easy kind of to put together. But that's definitely not the case on the server. And I sort of almost can't really imagine what that looks like on the server code to implement the server side GraphQL.
Yeah. I looked at your client right quick, and it looks like you specify the query as a string when you're making the query. And like you said, it populates the data. So in that case, you have the query string and the struct, and you have to keep the two in sync with one another. And so there's another client library, the Schema GraphQL client, that what it does is you use struct tags, and it will generate the query from the struct and then populate the data back in the struct. But that can get very complex because it's not as simple as JSON, where it's just the field name. You have to start passing arguments, and there are things like fragments and interfaces.
Well, that's sure cool.
Yeah, I guess the way I think about it is on the client, all of the complexity is like in the query and in the types that you're deserializing it into. And so I think Matt's client just kind of lets you deal with that, and it's really straightforward. I think Cool's client kind of tries to hide the query. You just write the types, which, like any kind of hiding things, is often convenient and then sometimes a little confusing. And then we can later talk about my client, Gen Client, that you write the query and it generates the types. But then on the other side, on the server, the types are actually a lot simpler because you just have your user type, and it's got a bunch of fields and a bunch of methods. And then the hard part is the server library itself that like glues all of that stuff together and actually has all this logic to say, did the user ask for an ID? Okay, then let's put the ID in. Did the user a name? Let's put the name in. Did the user ask for friends? Okay, which fields of the friends did they ask for? And that's where things really get complicated. So GQL Gen, which is the okay.
Yeah, so it's a perfect kind of problem for code gen, I think, that particular piece. And you mentioned earlier that there are like functions that basically are called, like if somebody asks for friends of the user, there's another function that's going to get called. So that goes some way to explain on the Go side, at least if you're writing a server in Go, how you could think about that there's going to be some kind of getter for the user and another optionally a way to then also load the friends of that user. And I don't know, do they tend to resolve down into joins in SQL in a relational database, or is that just completely up to really the implementation of the server?
I mean, it's up to whoever is writing the server and what the what the database is that you're using. At Khan Academy, we use a document database, so for a lot of things. We do have SQL here and there, but and you need a different strategy because with a SQL database, you can select just the fields you want, and in document, at least the document database we use, you get the entire entity from the data store, and so
So it sounds like using GraphQL on the server side is going to complicate things. So presumably it's solving some sort of problems to like justify all that added, complexity.
Yeah.
So can you speak a little bit to like what problems it's solving and like how it was helpful at Khan Academy?
Yeah. So Ben mentioned just REST APIs versus GraphQL APIs, where in a REST API you may be making multiple requests and stitching it together on the client. So I think it really does make it easier for the client. And we have a couple clients. We have a website, and then we also have a mobile client.
To me, one of the really nice things is that as someone who mostly works on the server, one of the really nice things is that you don't have to know exactly which client is going to want what where. You don't have to like if the front end developers decide like they want to add they need 3 more fields in this query, as long as fields are already in this because you needed them on some other page, like they can decide, they can just add and remove things. And so you don't have to, as a server engineer, you just say, how do we compute any data that we do need? You don't have to worry really at all about which requests need which data. The server library just like figures all that stuff out for you because the client just asks for it.
Yes, but haven't you really just moved the problem there, though? Like, at some point, we've got to decide what data we're going to load, and obviously, if there's a real separation between client and server, which if you have a public API, you have customers that are not part of your organization, so that's a significant separation. But if you were building an app and you just chose GraphQL, but no one else is going to use this API. You at some point have to decide what data you're going to load, and you may optimize that over time as well. By giving that, basically you're just empowering really the front end or the client really in this case. Isn't it akin to giving them like just to let them run some SQL? Why don't we just let them run SQL?
In some ways it is. But I think the nice thing about GraphQL over SQL is it's a much simpler language. If you wanted to try to like implement a whole SQL server that includes like your business logic, because you probably have, some of your, like if you build a really simple app, it may look like you're kind of just making requests to the database and maybe throw some auth on it or something. But in a complicated app, like, it all gets more complicated and you have a bunch of business logic sitting in between. And I'm not going to say you can't put that in a SQL server because there are certainly people out there doing it. And I think it's a cool idea, but it's a lot harder. Whereas GraphQL is really designed so that, again, it's just calling these functions on your server. And so if you have a function that knows how to get users friends, that's really all you need to implement that field. And so GraphQL is really, the server library is very complicated, but I think writing a server as an application developer, it's not that much harder than REST. You're really just sort of writing the same functions, and the entry points are just a little different. It's the entry point is the field instead of the entry point being like the whole API call. And for that, you get a lot of flexibility, and that flexibility, the client does still, on the other side, it is still tricky for the client in some cases to decide what information do I actually need, because you may have some like huge React app, and you need to know which of your components like way down the stack, what they're going to need. And so that is still a problem, but at least you get it, you get the decision like closer. So it's at least written in the same language, say, and you can then you can use a lot more of your tooling to look into that.
Yeah, and this is, of course, I'm glad you mentioned that there's better ways to do it than just doing it in SQL, because, of course, this is Go time, not stored procedure time. That's a separate podcast coming soon. Starring Jon Calhoun. Jon, you're going to do all about SQL and stored procedures podcast. Is that right? Or have I just made that up?
I hope I'm not. I hope nobody signed me up for it without letting me know.
Oh, he's nearly going to do it.
Some of these problems are interesting to me because it seems like people are approaching them from different angles. Like one of the more recent React frameworks was Remix, and I believe they're trying to solve some of those similar problems of not knowing what data you need sort of farther down in your React application. I don't know if either of you have used it at all, but essentially if I recall correctly, it's supposed to be something where like if your entire page has like a small section that's like a panel or widget or something that needs to load some data, it tries to make it so that starts loading the data like on its own API request if it needs to, without like it being a waterfall where like the first one goes and the second one goes and the third one goes and it's really slow.
Yeah.
So like I've seen people approach this problem, like you had said, Ben, where you need to kind of know what data the entire page needs, whereas sometimes they're just like, well, let's just not know what the entire page needs and let each thing load its own data. And there's pros and cons to both, I'm sure, but just seeing different approaches to similar problems.
Yeah, it probably
So-
comes down to organizational things even. Like if you've got a little team that are working on something, you don't want them to have a dependency if you can help it. One of the advantages I can see to GraphQL is that it does empower the client. So that means if there is another team that's consuming your API, they are somewhat more free to run ahead at their own speed. There doesn't have to be a conversation even. But then there's trade-offs to that. And one of the things that I was interested in is, now anybody can really build any kind of query.
Mhm.
Is it possible that they're going to ask for something that's very sort of inefficient and it's going to be quite an expensive thing to figure out? Whereas
Yeah.
if it was a RESTful service or if you were building an endpoint dedicated to a specific task, you could really ultra sort of optimize that. Do we lose some performance in the generalization of this?
Yeah. So when loading data for a single page app, right, you can load the data at the top level and pass it down through the tree, or you could have components own their individual queries and load a subset of the data. But to get to your question, you can construct queries that are very expensive to resolve, and so we're talking about client and server separation, but as a client developer, even with GraphQL, you can't be ignorant of what the server's doing, and vice versa. As a server, you can't be ignorant of what the client's doing.
So with
now
that power that you get also comes great responsibility.
Yeah,
That's essentially your message to them.
Right. You can see the queries that the client is sending to the server and exactly the data that they want, and so it does provide an opportunity to optimize for returning that data as well.
Yeah.
And yeah.
Yeah, that's a good point, because of course, if you even if it's inefficient, like you'd be able to run a report, presumably assuming you're instrumenting this stuff, you'd be able to find out where are the inefficiencies and then optimize it after, but without
That's right.
changing the interface.
Yeah. And then, I mean, another consideration is protecting a GraphQL server against denial of service, because if anyone can construct any query, then that can get very expensive. And so one strategy for that is calculating the complexity for a query and not allowing queries beyond a certain complexity. Another strategy which we use is we have an entire list of all the queries that clients are allowed to send to our server, called the safe list. And if it's not on the safe list, our server will not execute it.
So that's sort of like you let
That's
the
right.
clients free to build and ask for what they need, and then
That's right. Yeah, we statically gather those across the mobile client, across all of the backend services. And so we have a complete list, which allows us to do other very interesting things since we know exactly what data is being asked for everywhere. GraphQL, we also use GraphQL for communication between our services. So not just client, but service. Yeah.
Is that to have the self-similarity and the familiarity and all the dog fooding benefits of, or is it because you then also get to only select the data that you need? Like, do you use those features of GraphQL too?
Yeah, no, it's both, and we use federation to make it so the client doesn't need to know what services, what fields come from. Backend services take advantage of that as well, but it's mostly so the services expose one API, and we do have access controls where we'll lock down a field so that it's just allowed to be used by other services. But then we also have access controls where it's exposed in the public API. So,
So when you have like a list of these are the accepted queries,
Mhm.
how does that work with a public API where like presumably people would think they can kind of generate whatever query they want? Is it sort
Right.
of just in the docs of like you can't do certain things?
I think in that case, you'd want to go with the complexity approach and have some sort of perhaps like budget when the user is making requests, and if they go through their complexity budget, you start rejecting their requests.
Oh, that's nice.
It'd be
So you're
interesting to
also
see some of the
rewarding them for-
approaches.
Sorry, John. I was just going to say you're also rewarding people for keeping the queries simpler if it's a complexity budget. That's actually quite an interesting idea when you think about that.
I'd start to wonder if like you'll see some APIs that have rate limits of like this many requests per minute, and if they start to have like complexity limits instead of, you know, you can do as many requests as you want as long as your complexity doesn't reach a certain amount. That could be very
friends of
weird
friends
to
of friends
convey,
of
but
friends. Yeah, if you're trying to build an app that figures out how many degrees of separation between you and Kevin Bacon, this was a meme a few years ago. I'm trying to bring back, you know, then yeah, that would be expensive, complex. So you know, you maybe can't do it, but maybe it's actually not as well. Like, I don't know, like, you know, if you think about, obviously there's recursion going on, presumably. So if you have the case of like user and friends, and let's assume that the friends return a list of users, I guess that's the example that we're using. So then you can ask for friends of friends. And on the server, presumably that's just the same method being called twice, or the same function being called twice. Is that right?
it
Yeah.
would be called more than twice, I assume, because for
Well,
every friend, I would have to call that function. So that's
Oh,
where
I
quickly.
meant get friends, or the friends function, the one that loads the list of friends.
yeah,
If you then got
and
friends of friends. Oh yeah,
yeah,
multiple times. You're right.
and exactly what you're how you're fetching the data depends on the structure of your data, right? So if the friend has the ID of the friends, then if you only select friend and ID, that's going to be much less expensive than if you select the friend name. So it actually has to fetch the friend from the database to return the name. I mean, we're talking about the server bit, and we could talk a little bit about the mechanics of like what GQL Gen is doing if we wanted. I think something that's interesting to mention about GQL Gen is it's a schema first library. And so you write a GraphQL schema, which is defined in the spec, and you point GQL Gen at that, and from that it generates interfaces which have the various methods that you're expected to implement.
So there's a really interesting detail there, which I think we should probably shine a light on. You say there's a schema, and that schema describes the API. You get pretty good like discoverability with that, don't you? Like
you do, yeah.
There's an interactive web like client that the endpoint and gives you like IntelliSense. You can actually look at the objects, like it's kind of self-documenting. So it does feel very modern in that sense. And you know, that's also great for when if someone's consuming an API, having that at your fingertips, that sort of where you have autocomplete and features like that, you know, that is gonna for sure help. And consuming services, actually, I did consume a service that was extremely complicated and essentially was just, I feel like they basically dumped their tables through GraphQL. It wasn't much design or nuance to it, frankly. So that did make it quite difficult to consume.
And that's definitely something people do, and something that in writing a client has we've seen some interesting use cases come out. And it's they're using one of those things that just kind of turns your database into an API, which I think obviously have huge benefits as well, but they definitely make it a little less clean.
Yeah, exactly. I think you still have to design your API. And so, Mark,
Yeah.
you were saying that you take the schema and then you generate interfaces and things, which then
Yeah,
makes
that's what GQL Gen does. And so you're expected to implement the interface type and the struct that you create that implements this interface. That's where you can inject all the dependencies into the resolvers. If the resolver functions themselves are methods on this struct. And I also mentioned that when you're at the same level within the query, for the most part, the fields can be resolved in parallel. So they're all being resolved in different Go routines.
I think one thing that's worth pointing out here is that because it is a schema first, like GQL Gen is schema first, and because GraphQL has a schema, that means that this is a typed query language where you actually know what all the fields are. Whereas like when some people are used to like a JSON API, there's not really like a type structure that's strictly adhered to, and sometimes that can be insanely frustrating.
Yeah.
Like I remember working with one API where there was like one field on it, and if it had one item to return back, it gave you back a string with like the ID. But if there was multiple, it gave you an array back. And there was no way to like even if you like, because you could request, I forget, there was something with the request where you could actually request multiple. So if you requested using like an array with just one in it, it still just gave you a string back. And it was just one of those things that was like, who designed this? What were you thinking?
Well,
Like,
they're trying to be helpful, aren't they? They're trying to optimize. It's like it's really clever. If there's just one, it's a string. If there's many, it's a slice of string. Like that feels like intelligent in some way. I mean, you don't realize that actually. Yeah, I'd rather just have it as an array. I built an API once that was just all arrays. Like there weren't any objects because it made that. And you know, if there was only one object, it would be an array with one object in, because then you just could write it once. You could write an implementation that just looped over this data, and it worked for one and multiple. So you kind of get that for free. But yeah, I think you do need to still pay attention to your API design.
Yeah, and I was going to say we doubled down on making our GraphQL schema the authoritative place for our documentation. So attached to each field, you can put a doc string. Attached to each type, you can put a doc string. And so really in our systems, if you want to understand kind of the broad data model and how things connect together, you go to our composed schema, our federated schema, and can read through and get a pretty good sense. And we have a linter that enforces that some doc strings are written, and also that they have a consistent format, etc. Ben, you're going to say something.
I think one of the things about GraphQL, it's a fairly opinionated type system. You know, I mean, you can certainly have a type that's like string or list of string, but it's going to encourage you to do the list string. And it's because you are designing if you design your GraphQL, that's really what you make that decision, and where you say, this might be a list, so let's make it a list.
Yeah.
all right. So when it comes to actually working with GraphQL, and this is a Go Time podcast, so were there any challenges that you guys experienced that felt like specific to Go, or maybe specific to a typed language versus like using JavaScript or something else when using it?
Yeah, so I can talk a lot about this. So please, cut me off. But I think the first challenge we had, which will contextualize the client that we, the great thing about is it's a typed language, and the great it's a typed language, but you got to make sure those types match. If you make a request and the server thinks it's one thing, or the GraphQL schema says it's one thing, but the client thinks it's another thing, that's no good. And so what Gen Client does, and initially this was a challenge for us because we would have people like write queries, and if you don't manage to unit test it quite right, you put it into production and it's just like, sorry, that's the wrong type. And it's like, we're using a typed language. We should do better. And so we wrote Gen Client. It uses your queries and it uses the schema and it generates the correct types for you. So if you make a query that's incorrect, you can do that, but at compile time, it's going to say, sorry, we checked it against the schema. There's no field called name. It's maybe you meant name. And it's going to generate the right Go types for you. So you can't, if you thought name for some reason was an integer, like you can't, it's going to just give you a string. It's going to give you a type with a. And so that's something that I think is really powerful, especially using Go and using CodeGen and using a really well-typed language. You get the typing all the way. If you're using a library like GQLGen, where you've got good typing on the server, and you're using a library like Gen Client, where you've got good typing on the client, your types are checked all the way through from the client to the server. If you do everything right, and I think that's really powerful. And it also, it's not just. Sorry,
I was just going to ask a question on that. You asked me to cut you off, right?
Yeah.
Yeah. So and they both share the same schema, right?
Right.
So the source of the code gen is the same data. So see, because
Right.
there's another advantage to this. It's not just, I mean, it is what you've said, really, but as a sort of iteration development
Yes.
engineering process, like that, having that confidence of being able to, first of all, have discussions in an API schema is very powerful. When you're, front end engineers often have a very different kind of perspective to back end engineers. That can happen, but this is a common place that you are speaking the same language, really, and you can kind of collaborate much better there. But then not only that, once you then generate all the types, you're faced with like errors sometimes, and you have to fix them, and broken tests and things. And it's like, sounds bad, but actually that is exactly what you want. What's happening is the compiler sometimes is just pointing exactly to all the places that need your attention now, and that is an asset to have.
Yeah, and it really helps if you want to add a field, that's pretty safe. But if you want to remove a field or change the type of a field, you have to check that nobody's using it in a way that's going to break. And that's the kind of thing that if you have a typed server, you have a typed client, you just change your schema and you see where you get compiler errors all the way across the stack. And ideally, that tells you everything you're going to need to fix.
Yeah, especially if you're using TypeScript in the front end as well, so that you
Right.
literally have types there too. I mean, yeah, really.
Yeah, and a lot of the inspiration for Gen Client came from what clients that already exist in TypeScript that'll similarly generate your TypeScript types from your schema and then just use them.
Yeah, it's good, isn't it? I'm usually not a fickle man, but this episode has completely convinced me to now use GraphQL on the server. To be honest, I think I never comprehended. I thought it was writing SQL and writing join queries and things like this in the back end.
I think that gets
You can do
confusing
that,
because
but
like you see all these services out there that are like, this is a database with GraphQL built in, or we'll turn your Postgres database into a GraphQL client or server. And like, it is kind of confusing at times because you're not really sure what it's doing or how that's working or whether that's what you'd want.
Yeah,
which makes it a little bit challenging.
That sort of general approach can't be great. Maybe on small projects or, frankly, any small project, you can get away with a lot. Like, it's a great tip. If you want to write really robust software, don't make it popular. Just don't have that many users. If you can, I'm very good at that. It's actually where I shine. But like, and actually, like the whole idea of GraphQL, where you can ask only for the fields you need, in some cases that is just negligible, the difference that really makes in reality. So it's very interesting to hear about the other benefits and things that would apply even in smaller projects.
Yeah, like you said, the fields, like knowing that you don't have to request them all. I've definitely built some smaller APIs where sending the entire resource back just doesn't matter in the end of the day, or at the end of the day. So it's like that's not a real benefit for me. So it really just
Well,
becomes trying to figure out what makes the most sense.
even sorry.
Oh, you're good.
Even with that, I think the big benefit is really it's not that you can skip requesting name, like whatever, it's an extra 10 bytes or whatever. It's that you can provide those linkages to friends and friends of friends and friends of friends of friends, and you can decide exactly how far down that you want to go. And so it's really, I think, the relationships, and that's why it's called GraphQL, is like your users may be a graph. You can think of the schema actually as a graph, and you can decide exactly how far down that graph you want to traverse. And that's really where it's like you definitely don't want to include friends of friends of friends.
Requests like,
But you
can get away with including it in your schema.
Because the client decides, okay, I really just needed the friends.
So I guess I'm kind of curious on both of your opinions since you've built some stuff with this. Typically, when I'm like helping somebody learn to build an API or do something like that, my general advice is to start with just a simple like REST JSON API that returns some data. Mostly because if you only have one client and that's like you're writing that one client and you know exactly what data it needs, you can kind of tailor it around that. Now, granted, at some point it might get so complex that you need something else. But generally speaking, I'm kind of sort of an advocate of keeping it as simple as possible, especially when you're learning, because you can't learn 17 things at the same time. It's just not possible. And GraphQL, from what I've seen, at least, it's not that it's overly complex, but it's also not like pick it up in 30 seconds and move on with it. It's going to take a little bit of learning.
Yeah,
so
that's right.
I guess what is your advice on sort of when to get started with it? And then can you share a little bit about like how you guys got started, resources, that sort of thing?
I started when you
Start to find REST frustrating. When you find
it's like I have to go
change all these 6 different APIs because I wanted to change one page, or now I have to figure out who's using that API because I wanted
to make a change to it, and it's used by 16 different pages, and who knows what they're. When you start to see those problems,
GraphQL is going to help you.
and
If you're not seeing those problems yet, if you're in a small enough project that you can just build your REST API and build your client and keep it all in your head at once,
and then
that's fine. I think GraphQL is going to be unnecessary complexity for you.
But it's
really and that's really what we did at Khan Academy quite a few years ago now. Is we did have this huge REST API, and we did have and it was a huge pain to go look through. Okay, how do I want to remove this field because it's expensive.
Once is it?
Yeah.
And
that's really when we started to pick up GraphQL,
when it really
helped us all.
Yeah, and I was going to say we also have some tooling, or had some tooling for typing REST responses. And so, if you find yourself building out that kind of tooling, perhaps using something that's going to, assist you, has that already built in, is a good option.
Yeah, that makes a lot of sense. And like earlier, I mentioned like the Stripe API, and if I understand correctly, they have a ton of tooling sort of built around like what they do. But at the same time, I think some of these companies had to invent stuff back when like GraphQL didn't exist. So it's like, how do we make this work knowing that's not an option?
Would you use GraphQL if you didn't have
Yeah.
relational data in any way? You'd still would use it now. I don't know if there's lag there.
I think Ben said yes.
Yeah.
Yeah, cool. Simple as that. Yeah,
That's all the answer you
move
get,
on.
Matt. Just
Yeah,
yes.
yeah. No, fair play. No, just a Boolean answer. I like it. Maybe you could answer in a string now.
Ultimately, most data is
I don't know. I think mostly like most data is somehow relational. Like there are relationships between your data. If there's not, like what is the data even? There are certainly exceptions, but I think if you genuinely have like just like your entire data is like one big table, maybe you don't need GraphQL. But I think almost everybody has some kind of relations, and you'll find value in GraphQL with those.
I guess one question I have related to that is, like if you're releasing a public API, like GitHub is an example of one that's a GraphQL API. Do you feel that releasing it as a GraphQL API makes it harder to get adoption, in the sense that like people are there's a certain subset of developers who know how a REST API works and they're kind of comfortable with that. Then you throw something new in the mix and they're just like, I'm not going to use that API because it is that new thing. Like,
Yeah,
do you
I
think
suppose there is
that's
also
true?
a bit more cognitive effort to actually deciding what data you need and discovering that, whereas it's much easier to just say, get this thing. But in reality, like, what difference does that really make?
Yeah, and I think writing GraphQL queries, it's pretty intuitive. And so, Matt, you mentioned tooling where you can write a query, select a field, and actually that tooling will pop up. This is the type, and here are all the other fields that it has and the documentation for those fields. So it does help with discoverability quite a bit as well. And I think that's a great place to start learning GraphQL is just try writing some queries. It's a pretty easy entry into it. And at graphql.org, it's a really good overview of just if you want to learn just more high level how GraphQL works as a spec. GraphQL.org/learn. You can run through those pages and get a pretty good high level overview.
All right. We're getting sort of near the end of the episode. So is there anything else you guys would like to talk about before we move on to unpopular opinions?
Wow. Yeah.
Related to GraphQL, please.
Yeah, I know. I think this is pretty good. We had it on the list to mention federation. I mean, something I can mention, right quick around that is you had asked what advantage GraphQL was giving us at Khan Academy, and we moved from a monolith written in Python to Go services, and federation was key in being able to do that.
What do you mean by
and
federation in this case?
Yeah, so this is where different services own different fields, and you send your query to a gateway instead of a single backend service. It will figure out which services to contact or to connect to get that data and stitch together and return it. So we treated Python as just any other service. And then when we started building out the Go services, we built some tooling that would send requests to both Python and Go. It would compare them. It would send the old requests to the client. It would tell us if there are any differences. So
that's cool.
Yeah, it worked really well.
It's the federation's one of those things that I've looked at because it looks cool, but I've never had a project I've been working on that's like at the scale where this makes sense. So it hasn't been something I've actually dove into. So it's interesting to see that worked for you guys, like for your particular use case of migrating.
Yeah.
Okay, Ben, I'm going to give you the same chance that I gave to Mark, assuming you're here still. We're going to move on to unpopular opinions here in a second, but is there anything else you'd like to discuss about GraphQL before we do? And I think we lost him. All right, let's move on to the unpopular opinions.
Have you got the theme tune?
Well, I'm trying to, but
it's
I don't know if
preview
it's
and
working.
live at the bottom. Oh no, you played the theme though.
Yeah, I
now
played
we've
the
got two
theme.
Bens. Two Bens there. Ben, see if you can match the face exactly of the other Ben.
I can't see the other Ben is the problem.
Oh, you can't see the
That'll
other
make
Ben.
it even harder.
Even better.
Oh, it's gone now.
Oh, Oh, he's gone.
Okay, so I can't play the theme for some reason. I don't know if it's like bugging out or what.
Shall I try?
If you can.
No.
Apparently when Ben disconnects and reconnects like 18 times, it just says, nope, we're done.
Yep.
Don't have any internet left. Yeah, it's just.
I
Not
just
playing,
didn't
is
want
it?
the theme. That's it.
Well, with tough luck, I'm going to play it live. That's why I keep my guitars nearby. Not really gonna do that.
I mean, that would definitely make it to the episode if you did, but.
Exactly. That's why it's not happening.
All right. Mark and Ben, do you have any unpopular opinions you would like to share with us?
Sure. Yeah. So, my unpopular opinion. So I think manually grinding through work is a underrated engineering strategy. Right? Computers are great at automating tasks that you know how to do, and you have to know how to do something really well manually, I think, before you can effectively automate it. So you see this in product development, where startups will just have staff members doing tasks instead of their API, automatically doing things, as they're building things out. But it also applies, I think, to other areas of engineering, where it could be that perhaps the task isn't even worth automating. Or I really like the approach of kind of assisted automation, where you let the computer do what it's really good at doing, at perhaps finding places in code to update, but then you just go ahead and use your ability as a person to actually make the updates. So
Yeah, I think that's a really interesting one, because it's something I've learned. It didn't come intuitively to me. That's something I had to learn over years of getting it wrong, basically. I definitely have an instinct to jump too soon into automating things, because the process of solving that problem is quite nice and rewarding anyway, especially if you're, because we're kind of programmers, aren't we? We're like problem solving and things. But you're so right. And the point you made about you should be able to like manually do it first, like enough to know it inside out before you automate, it applies to lots of things, I think, too, and has so many benefits. Not just like the learning of it, but I think just probably is just that learning of it, the knowledge you get from that. Good luck with that, editor. Good
No,
one.
I find it. I feel like you're going to have a hard time for that one being unpopular. I feel like you're going to have a lot of people agreeing with you. Maybe especially developers, because I feel like developers make that mistake a lot.
Yeah.
Of like wanting to automate things.
Yeah. I mean, it's really the manual grind. Like sometimes I'll need to make updates across all of our services, and there's literally 200 things to update, and figuring out how to do that in an efficient way. Automation is not always the answer. Some aspect of automating some aspect of it usually is part of the solution, but not working on a tool to do that. Just a specific thing that you'll only be doing once.
Like I can give an example of I make video courses that like teach programming stuff, and at first it was really tempting to build my own sort of admin page that I'd upload a video and it would do all these things for me, like create a thumbnail, change all the stuff and do it all. And I kind of fought the urge to do that, because that was like I'd have to interact with a couple APIs and do some other things. And what I found was that in reality, going to the website that I host the videos on and just bulk uploading 50 videos by dragging and dropping with my mouse, and then running FFmpeg on my own computer to generate thumbnails, and just basically naming them 01, 02, 03, and just uploading those, ended up taking a little bit of time, but it was way less time than it would have cost me to like actually go develop all this stuff that I really didn't need, because it wasn't like I had a platform that people were all hosting stuff on.
Right.
So it wasn't like it's completely different if you host a platform, but when it's just you doing something, it's like, is this really worth it? And it's really hard to say no, because that sounds so much fun. You're like, oh man, I'm going to get to use this API. It's going to be fun.
It's such a good example, that is, John, because that is, even now I'm thinking, definitely automate that one. Like even just that description of it in the story where you're saying you learned this lesson, even then, I'm still like, yeah, that would be great. That would be that's prime for automation. That. But Mark, would you resist that urge?
Yes. Yeah.
Yeah. Boolean answer. Yes. Cool.
All right,
Okay,
Ben, while you're here, do you have an
Yeah,
unpopular opinion?
I just didn't want to give an unpopular opinion. That's why. No, this may also not be that unpopular, but I think that Go really needs union types, like proper disjoint union. I think generics are just like making this really obvious. I think it's especially obvious because they kind of halfway added a union types except they only exist in type parameters, and it's kind of more of an untagged union. I think enums are a case of this. I think people using pointers as nullable. When you don't need a pointer, you just need something that's nullable. I think there are so many cases where it's just like we really could just use union types, and I know they want to take the time to add it right, which I support, but I think it's really getting to be time.
For anyone that
So-
doesn't know, what is a union type, Ben?
Yeah, sorry.
That's my
A
question
union
as well.
So a union type is when you have something like it could be an int or it could be a string, and I think there are a lot of sort of distinctions of there are slightly different ways you can think about unions.
You got a little choppy. And he might be gone.
Hopefully, it records on his end so that we can capture this thought. Yeah, it sort of sounds like a
Yes.
Terminator's got into jazz. Sorry, Ben. Ben, we talked over you then,
Ben is
but
back
if
again.
he's coming in, they've got two Bens.
I'm back.
I was
Ben,
gonna say
sorry.
if you do it and you have it recorded locally, like Matt was saying, we can try to edit that in, but
Yeah.
or you can try
Sorry.
again now.
No, I think I have it fine on my end. So
Okay.
So there you
I
go,
was gonna
yeah.
say if your
Unions.
unpopular opinion was that your ISP you have is very good,
yeah, well, no, my unpopular opinion is I might need to switch to the terrible ISP whose service everyone hates. But
I feel like there's lots of potential ISPs for that.
yeah,
I love mine. I'm one of those. I have a gigabit fiber symmetrical. It's
yeah. Sadly,
Magical.
we could not get that at this apartment, and
it's worth like running your own fiber around the streets if you can.
I wish.
Yeah. No one would move it for a while, I think. If you knew someone nearby that had fiber, just while you do the podcast, just get
Okay.
a really long.
Yeah.
Oh, sorry.
Yeah.
Can I tell you a story about this,
now.
Matt? Very
Yes,
related.
please. Yeah.
So when my wife and I were building our house, I lived with my parents, and their internet was terrible. And I later found out it was because their one DSL line runs underground, and apparently there's like water getting in. So when it rained, it would just be had like a really bad connection.
Oh.
So apparently it's something, I don't know the exacts, but it was something with like the union with it and everything. It's hard to get them to prioritize this job, and they can't send anybody else out to do it. So it was kind of limited on options. And somehow at one point they got somebody to come out to run a new line, but it went into a neighbor farmer's field. So it's like just sort of dangling from a pole there, and then it like ran through his field. So but like their internet was like twice as fast. So it was like great for a while. And then one day the farmer came through to actually,
Tilled the
chopper
land.
to actually plow his field with something or whatever he was doing with cutting stuff. And he didn't know that line was there. So all of a sudden the internet just went out. And then when they came to check it, basically what had happened was he had went over the line and just sliced the crap out of it. And they had to go back to the old line at that point. And they like never sent anybody else out to fix anything or do anything with my parents' internet.
Oh,
And I was like, it just shocked me because I'm like, who thought this was a good idea to just run a line through some farmer's field and not tell anybody?
yeah, amazing. That's amazing. I mean,
That's
yeah,
gonna be
I love
me and running my fiber. It's
that
gonna
story. Yeah.
wait until
Just avoid
somebody
the
runs
farmers'
over.
fields. Or just in the streets, I think, though. Like,
Yeah.
that'd be good. Yeah, that'd work.
See, I have decent internet at my place, but if you get outside of like this small town that I'm in, where there's a bunch of farms and fields and stuff like that, it when I was growing up, it was awful options everywhere. Like satellite internet was sort of an option, but like you always had like these bandwidth caps that were so low that it was really hard to use, and everything else. And it's like slowly gotten better. Whereas like now they have something where they like have a big tower, and if you're like within direct line of sight, or if you can get like a receiver within line of sight of it, it's not terrible. But otherwise, you're just kind of out of luck. So it's kind of interesting
Sounds
to
like
see.
you live in a dystopia, like a Netflix special where you describe this unusual village with really modern internet surrounded by. You know what I mean? I feel like this,
I think the
it
only
sounds
reason the
like
internet is like modern in this small town is
Hmm.
because there's so few people that they like have cable. Like Comcast has cable set up, and there's just not enough people for it to actually be slow.
no one's using it, so it's so fast.
Yeah, pretty
It's
much.
just
That-
ADSL.
like I have an uncle who worked at Comcast, like not like directly, he like worked on the lines and stuff, but he used to joke that
Oh.
whenever I moved back to this town, that the internet got half as fast
Yeah,
because I'm like one of the heaviest users. That's what he would
Put me
claim.
on
Like
it.
he was just joking, but
yeah.
yeah, it's I don't know.
I
It's,
know he
it's
was
interesting
joking,
different
wasn't
places. Sorry, Matt.
I knew your uncle was joking.
Well,
I think I'd like him.
maybe.
Can I have his number?
I don't
That'd be
know.
weird, wouldn't it?
I
it
mean, it'd
wouldn't-
be
it
more
wouldn't,
weird
no,
for
it
him,
would-
I think, if you just called him.
Yeah.
What is this long distance call?
But are you Jon Calhoun's uncle? Yeah, it's me. Matt. Yeah, what would he do? Should we do it now?
I don't think that's a good idea.
Oh, okay, well, we need to do next week. We'll get ready. We'll do a new regular section, phoning someone's uncle, and we'll just phone up an uncle and see what's going on. Uncles usually have the most interesting views and some very unpopular opinions.
I was going to say, based on where I live, I have no idea what type of unpopular opinions I might get from uncles. So that could be
in your
scary,
dystopian Netflix village.
pretty much.
Yeah.
All right. Mark, Ben, thank you for joining us. Matt, thank you for hosting with me. Sorry
Pleasure.
for the poor intro.
It's all right.
We'll get it right sometime.
Nah,
You know.
Thanks
better
for having
like
us.
this. Yeah,
All
thank you so
right.
much.
Yeah,
It's nice
thanks
to
for
meet
having
you
us
both.
on.
So at this point, I'm going to try to play the outro music, but yeah, it's not working. That's what I figured. I really don't know why it broke.
Yeah. Have you tried toggling? Oh, have you tried toggling preview and live again? It's the equivalent of turn it off and on again, John.
Okay, so when I went to preview, it just played it really loud in my ears.
Yeah. Now you've gone back to live.
No,
Is
like
it
without me
saying
pressing
going
anything
live?
else. So I'm going to live to see.
Okay. I'm gonna try it. Oh, I heard something. Was that you or me, John?
I heard something.
This is professional.
I'm like convinced that the audio for that is like attached to Ben's internet.
Yeah, that's
somehow.
where we host it in Ben's data center. Ben, we're not happy with this.
Yeah, that's
There you go. It worked.
There we go.
It was 8-bit though, but probably just because of the bandwidth issues. Came out, it sounded 8-bit.
All right, Ben.
It'd be good if that's
Let
what
me
it did to
get you-
music. When you listen to music in low res, it comes out like 8-bit, like it was made on an old Spectrum. Or
All right, you guys can all stop your recordings. Ben, there's a link in chat. You definitely have to upload. Well, I'm guessing you have to upload yours.
yeah,
I can't imagine it worked otherwise.
yeah. No, I will.
yeah, otherwise it's going to be me doing an impersonation of you, filling in the gaps, trying to guess what you said.
We can do it.
Give me.
Can't wait. I've been pitching to do this for ages and they've never let me. So please, that audio gets lost. I'll just save my audio, John, shall I, on my hard drive?
Yeah, that works. I mean, you can upload it if you want. I'm not going to complain.
Okay. Right.
All right,
That's
it's
really
gonna
good. I feel like. Sorry.
it's gonna take some time, but it's uploading.
That's
Oh,
okay.
it's ticking down at like 1 minute every second. So
So inside of Riverside,